7.6 is about common logs, common logarithms, and this is on this screen is on page 1124 in your book if you'd rather screenshot it. But the long story short is logarithms all have a base. The common log is just a logarithm of base 10. We just don't write it. So the log button on your calculator means log base 10 without we just don't have to write the little 10 in there. So let's think about a couple examples of when in math, we understand what something means without actually writing it. So for example, x, we know this equals x to the first. We just don't write the 1. Okay? We just recently talked about radicals. And the square root of 49, we know that this could also be written as, we could put the little 2 as the index, but we don't write it. It's the same idea with common logarithms. We just don't write the 10 since our whole number system is base 10. The log button on your calculator means log base 10. And so here's an example of what your calculator would look like. So that's the log button. If you press that button, it means log base 10. Okay, so for these next couple examples, I just want you to get used to using your calculator. So what you're going to do is hit the log button and then 7 and hit enter, and you're going to get this big long decimal, and I want you to round it to 4 places. So for these two problems, go ahead and pause the video, type those in your calculator, and let's see what values you get. Keeping in mind that logarithms are just powers, what we're saying here is 10 to what power equals 7. So it's going to have to be less than 1 because 10 to the first is 10, and obviously 7 is less than 10. So what you should have gotten for A is 0.8451, rounding it to 4 places. And then when you get log of 1/2 or 0.5, you get negative 0.3010. And all you're doing is typing this in your calculator just like that. And this is the power that you'd raise 10 to get this number. Okay? So that's the common log and how that works on your calculator. One of the main reasons that we have common logs or any logarithms is to solve equations. Okay? And this type of equation, an exponential equation, is when the variable is in the power. We had some problems like this before. And they looked something like this. But what always was able to happen is I could rewrite this number as 3 to some power, then set the powers equal to each other. Well, I can't raise 15. I can't come up with the number 3 to some power equals 15. And so, because the only way to come up with 15 is 3 times 5 or 1 times 15. And there's no way to take 3 to a power because 3 to the second is 9. 3 to the third is 27. It's not going to work. So the way that we get this power down is by using essentially one of the properties that we learned about in our previous section, that being the power property. So what we're going to do in situations like this to get this power down is we're going to take the common log of both sides. Okay, and what this does for us is it allows us to take this power and bring it down in front using the power property. So what I have is, by taking the log of both sides, it allows us to bring the power down, and so it just comes out in front. So now this is x times log of 3 equals log of 15. All I need to do now is, since I'm trying to solve for x, is get the x by itself. And since x is being multiplied by log 3, we just divide both sides by log 3, and then they cancel out. On this side, the log 3 will cancel, and on what's left on here is log 15 over log 3. So that you type in your calculator. Be careful. One of the things you want to do when you type this in is, because when you hit the log button on your calculator, it will automatically give you that left parenthesis. Be sure to close the parenthesis. If you don't, it will try to take the log of 15 divided by log of 3 all inside of these parentheses here. So the calculator will think this is all supposed to be inside here. So make sure you close the parenthesis around the 15 before you put the division symbol, or if you put it in a fraction. Now if you put it in fraction form and in fraction form on your calculator, then you'll be okay. But if you just use a division sign, it'll try to calculate it incorrectly. And you can play around with that. Try it both ways to just to show you what I'm talking about. So anyway, when you enter this all in, that will get me my value for x. Now, before I go on to the next slide, let's think about something here. Since my original problem was 3 to the x equals 15, and as I mentioned, if x was 2, this only equals 9. So that's too small. If x was 3, this all equals 27, 3 to the third. So it's got to be between 2 and 3. Because 3 to the second is 9, 3 to the third is 27. We're trying to get 15. So it's going to be somewhere in the middle, and it is. And with logarithms, we're going to round to 4 places. So 2.4650. If I raise 3 to that power, it's going to give me 15, or about 15 since this is rounded. Okay. So anytime we have problems like this, where I have a variable and a power, I can just take the log of both sides, and that will bring the power down. Okay. So let's look at another example. Same type of problem, 6 to the x equals 42. So if you want to try to work through this, go ahead and pause the video and try to see if you do it correctly. Same idea. I can't raise 6 to the, the second power is 36. The third power actually is 216. So it's not going to be nice. It's not going to be even. And 42 can be 6 times 7, 2 times 21. There's no way that I could just change the base so that these are the same. So we end up taking the log of both sides, just like we did before. Okay, the variable comes down. Okay, then I divide both sides by log 6, and then the x is by itself. So I get log 42 over log 6. Again, make sure your parentheses are closed around the 42. You get 2.0860. We're going to look at this problem again here in a second, and I'll show you why. Okay. There's one other topic in here that we need to talk about here. Okay, if you notice, the work that we ended up getting was log of 42 over log of 6, which was this. Instead of taking the log of both sides, I just rewrote it in logarithmic notation, and I 2.0860. And that is the change of base formula. And this is on page 1128 in your book if you'd rather screenshot. Essentially, we can use common logs to solve when the base is not a 10. So if I have log base a of n, I could rewrite it as log n, so common log n, over log a. And here's another example. Log base 3 of 11 is the same as log 11 over log 3. So the bottom number is the log of whatever the base is. The top is the log of the normal number there, okay? So the directions in some of your problems are going to look like this. It's going to say express, and this is log base 3 of 20 in terms of common logarithms. So that means this. Write it out like this, then plug it into your calculator. So there's going to be 2 parts to problems like this. The first thing, okay, since the bigger number goes on top, the base goes on the bottom, I just need to write it like this. In this case, it would be log base 20, log of 20 over log of 3. Log of 20 over log of 3. So that's the first part. The second part is just punch that in your calculator and see what you get. And we get 2.7268. Now I want to go back for a second because some of our problems looked kind of like that. This problem that we did, where we took the log of both sides, I could rewrite it in logarithmic notation. And I could solve it the same kind of way now that we have the change of base formula. So if I wrote this in logarithmic form, remember I'd have log, the base is 6, it equals 42, and the power is x. And you say, okay, well, what good does that do me? Well, what that does for me is I can now rewrite this using common logs, using the change of base formula like we just did. And so this would be log of 42 over log of 6 equals x, which we already did this problem. So if I go back to this problem right over, I get the same, eventually I get the same work, which will give me the same answer, which was, I already forgot what it was. So what I'm saying, what I'm trying to tell you here is there are two different ways to solve a problem like this. Now that we know the change of base formula, we could rewrite these problems in logarithmic notation like this first and then change the base. Or we could take the log of both sides like we did the first time. I don't care which way you do it. It's up to you. But we needed this change of base formula before we could give you this option here. But now you have it. So those are the two main concepts in 7.6. Knowing what the log button is for and the common log, and then the change of base formula and how to deal with that. So just keep in mind, you can work through equations like this either this way or the way I did it a few slides ago, taking the log of both sides. It'll be up to you.